So I hope my screen is also visible now. So can I get a confirmation of whether my screen is visible?
One second, sir. Yes, sir. It's visible, sir.
Okay, thank you. So a very good afternoon to everyone present here. For myself, Ram Prakash, working as a senior application engineer in VI Solutions Bangalore. So yes, I'll be handling today's session. So I'm not sure what number today's session is, but I hope yesterday you people just want to know about MyDAC, which is the acquisition hardware by NI National Instruments. So today I was told to give an introduction to the next level of hardware. Okay? So in the hierarchy of hardwares, uh, which you have under NI, right? So there are many hierarchy of hardware. So yesterday just got an introduction and the programming basics about the NI MyDAC, which is a basic wire data acquisition hardware. Okay, so which can do some basic but very precise data acquisition of any signals, either can be analog as well as digital, can handle both. So I hope these things were uh, taken by another person to you. So today I'll be introducing you people to a new hardware. So under the hierarchy of the national instruments, right? So that will be my Rio. Okay, so that this my Rio. Okay, so we are going to see the basics and just overview of that hardware. So tomorrow you'll be getting the hands-on session, or we'll be showing you how to just acquire any signal and what is the difference between what you saw yesterday and what you're going to see today. So that will be shown with the hardware tomorrow. So today, as of today, as we got only 1.5 hours, so I'll be giving an overview with all the specifications and what are all the things which you can do with this NI MyRio. Right? So that will be about today's session. So yes, I hope I can start. So I hope there's no problem regarding my voice and the screen I share. I hope everyone can see my screen. So yes, I just opened a document which contains the specification and overview of the NI MyRio. So this is an MyRio user guide and specification. So this is available in the internet. So you'll be having this document for all the hardwares which you like to see regarding NI. So before going through this, before going through the user guide and specifications, let me say exactly what the NIMI Rio is and what is the difference between the NIMI Rio and my DAC. Let me show you the picture of my Rio. So yes, so this is how exactly the NI my Rio looks. So yeah, it has loaded. So this is how exactly the NI my Rio looks. And let me open another tab and let me open NI my DAC. Go to images and I'll take this picture. So here is my DAC, so which you got to know about what this hardware is. So you would have gone through this in yesterday's session or the previous session. So today we are going to deal with this hardware. So what is the difference basically you can see in between these two? So look wise they are similar or the size wise they are similar, but yeah, the color theme is different. This is white theme and this is dark black theme. And this my Rio also have some major advancement or difference when compared to the NI MyDAC. Okay? So as you would have seen yesterday, so the MyDAC contains these things, right? So it is USB controlled power, right? So you don't need any external power supply for powering up the MyDAC. You can just use your a normal USB cable, so which can be connected with MyDAC. So this is just a plug and play device, right? So, and regarding the specifications, it has two channels of analog input and two channels of analog output, each carrying 200 kilo samples per second sampling rate, and both of them are 16 bit. And regarding the digital signal, if you want to generate or read any digital signal, you have 8 lines for that, each under a single port, which can be found in the right hand side of the device. And regarding counter, say that you have to generate a PWM signal using your device, you have one counter which comes together with the DIO. So one of the DIO pins will act as a counter or a PWM generator. And that device has an integrated multimeter, a digital multimeter, which can measure voltage, ampere, and ohm. And it also has an inbuilt power supply, which can give you either plus 5 volt directly or an analog supply of peak to peak 30 volt actually, which is plus or minus 15 volt. And it also has two audio jacks, okay? The audio in and audio out 3.5 stereo jacks. So all these things are present in this my DAC, right? So which we worked with yesterday. And there are also some soft instruments or virtual instrument, which actually I introduced to you. So these are all available pre-installed with your software. So yeah, you'll be having this DMM, oscilloscope, function generator, the Bode plotter, everything you'll be having when you install this DAC software suite. You'll be getting all these things. So this is a general overview or just a recap to the NI MyDAC. So whatever this MyDAC can do, right? This MyRio will also be able to do. So everything a MyDAC does can be done by this MyRio. Then what is the advance? What is the advancement? So that is what I'm going to be sharing you with you people in today's session. Right? So look-wise, you can see in the MyDAC, you just have ports or any connections can be made only in the right hand side part. Right? In the left hand side, you actually don't have anything in the MyDAC, but in the MyRio, actually have two separate ports here with a many number of lines. Okay, so yeah, the first advancement regarding the my Rio is that it has more number of pins. Okay, so you can enjoy the facility of connecting more number of sensors or generating more number of signals from your device, which can be done using your my Rio. So yeah, you are actually have very limited number of channels regarding analog and digital channels. Like you have a very minimal number of channels in your MyDAC, but if you take MyRio, you just have a lot of channels which you can be used and which are also user programmable, right? So yeah, that's the first major advancement. And the next advancement or the next feature of this MyRio is that this MyRio can be connected wirelessly. I'll go to chat here. Yes, thank you. Good afternoon. So yes, this MyDio can be connected wirelessly. So regarding the MyDAC, the NI MyDAC, right? So that can just be connected using your USB cable to your PC. But this MyDio can be connected wirelessly, okay? As you can see. I hope you can see the logo here. There is a Wi-Fi indicate LED here. And so which means that this MyDio is capable of getting connected to a device wirelessly. Okay, you can use your Wi-Fi. Just turn on your hotspot or hotspot in your PC and connect it to your Rio, or the other way. You can also turn on the hotspot which is present in this My Rio and connect it in your PC. The both things can work. And yeah, that is the second advantage of this My Rio. The third one, so this is not an I cannot directly say it as an advantage. This is also a particular feature of this MyRio, which is that the MyRio requires external power supply. Okay. As you can see here, open this picture, you can see the bottom portion of this MyRio. You can see there's a port called power. Fine. So yes, this MyRio requires an external power supply. So apart from what you plug into this USB port, right? You must have to use this socket or use this port to connect to an external power supply of 12 volts. Okay, so that can be even a battery, or if you have, you'll be getting an AC adapter when you buy a Myriad. You can use that, or if you want your device to be moving freely, you can use a battery and connect it to it. Okay, so yes, this Myrio requires an external power supply of 12 volts. So apart from that, you also have an USB port. Okay, so the use of USB port here, why do I need actually an USB port into a controller? So that will be explained later after I say you about this feature. Okay, so this My Rio actually has an inbuilt operating system itself. Okay, yeah, this is a standalone controller, meaning that this MyRio can be able to run a program without even your PC. Yeah, this is a standalone controller, and this has inbuilt operating system as well as FPGA. Yes, this has a FPGA inbuilt in this hardware itself. So this is how the hardware looks. Right away, if you look peep into this glass, right, you'll be seeing the processor, which is Xilinx Sync 7010, which will be present inside your Mario. So that is this operating system will be a Linux-based operating system, so which will be able to run your program as a standalone, like how the Arduino does. Right, you'll be burning your code inside your Arduino, and even if you disconnect that from your PC, the Arduino will be able to run your code whenever it is powered on. So your NI Mario also has a capability of working in the same way. Fine. So this can be used as a standalone device. And yes, it also has FPGA in it. So if you wish to work with FPGA, yes, this hardware can be used. I hope I'll now peep into this user guide and specification. So after just reading all the specifications, let me show you just how to connect or what will happen after you connect your PC, how to just make all the configurations ready for you to program with this NI Mario hardware. So after just reviewing all the specifications present here, I'll just go on to that. So as I said, I hope I'll just make it a bit large. This is how the hardware looks. Yes, it has, as I told, it needs an external power supply of 12 volts. You have the normal USB port, USB pin, through which you will be connecting it to a PC. So before connecting it to wirelessly, right, you will be asked to connect it to your PC to just change the configuration. So even if you want to connect it wirelessly, right, you have to say to the Rio whether it has to create a hotspot or it has to connect to any hotspot um, actually present in the band. Okay, so that you have to configure manually. So for that, first you have to always connect your NI Mario to your PC with the wire. And after you make all the configurations and after your devices are connected wirelessly, you can remove it. And you have this USB port. Yeah, I'll say about that later. And the right side part is actually the very same as your my dad. Okay, so it has two analog input channels, two analog output channels, and 8 DIO. So regarding the right side of the device, this is actually same as your NI MyDAC. And it also has the audio in and out pins. Right? So apart from that, if you see the bottom side or the face part, you have two buttons. So one is for the Wi-Fi. Okay, so to turn on and turn off the Wi-Fi module present in this MyRio, and the other button is user programmable. Say for example, you want to use this device as a standalone device, and somehow you want to use this button itself. Because a standalone is nothing but you'll be not controlling your device using your hardware. You will be just burning your code into that device, and yeah, whenever you power on, the particular code will be running, and everything you coded right, so that will be happening continuously. So say that you want a control. Say that only if you press this button, that particular code should run. So if you have a certain requirements, you can use this button. So this button is a user programmable button which you have here. And to the left hand side, I hope you remember what you saw in the picture in the Google. So that also have two pins, two ports, actually two separate ports, so which actually contains 34 individual pins. So that either you can connect it directly wired or you can use this MXP connectors. Okay, so this we call it as the MXP connector, which you'll be getting it with the Rio kit. Only one will be included with the Rio kit as mentioned here. So this is nothing but an expansion port, okay, the MyRio expansion port. What you can do, you can just make your connection will be made easy. Okay, so that's about the overview of the device. So let me just try to move to the next page. Yes. So speaking about the hardware overview, so as a basic controller or as a basic microcontroller will have, this NI provides you with the analog inputs and analog outputs as well as digital input and output. You have the audio input and output, and also you have some power supply as you had in your MyDAC. Okay? And this get connected to your computer, the house computer, with USB and wireless. Yeah, it has a Wi-Fi installed in it. So as I said, this has a inbuilt operating system. Your Rio actually has an operating system. So that okay, so that if you want to run the code using that processor itself, right? So that we call it as LabVIEW RT, okay, which means that LabVIEW real time, or else there is actually two ways. Either you can use the processor itself directly, or yeah, the most advanced way to program is that using an FPGA, right? So LabVIEW, sorry, the NI MyRio has inbuilt FPGA in it. So using this also, you can do your program. So there will be no parallelism, and yeah, you know the hard advantages of using the FPGA in your programs. Yes, you can code with your FPGA also, and you just know that there is actually an operating system or a processor itself present inside your MyRio, as well as we have an FPGA installed to it, and as I said, you have this button. So another additional sensor you have in your MyRio is this accelerometer. Right? So yes, you have a pre-installed accelerometer in your MyRio. So yeah, uh, I hope you know how an accelerometer works. So you just have your accel. So once I connect my MyRio to my PC, right, I can show you. Directly it will just take you to a page where you can just work with all the onboard devices. So the accelerometer will be called as an onboard device. Okay, so because this accelerometer is present in Rio itself, so I have not connected any sensor to it. It is just present in the Rio itself. So apart from this, I hope you can see in this picture, we have some LEDs here. Or just me, let me just open Google. So if you see here in this picture, you have some LEDs here. So these four LEDs, like the LED 0, 1, 2, and 3, are user programmable. So you want to show some indication for everyone. So regarding your program, so these four can be programmed by the user. Okay? And this is the Wi-Fi on or off. This just shows you whether the Wi-Fi is on or off, and also whether it is connected or not connected. Right? And this shows your status. So this actually works like a reset, like you have in most of your controllers. And yeah, as usual, a power indication key. So this will be turning on once you power this NM area with the 12-volt external supply. So that's it about the hardware overview. So let's just go to the pin outs. So this is how the left hand side of your MyRio looks. So this is actually not present in your MyDAC. So this will be called as MXP connectors. Okay, so this is port A and this is port B. So these will be male pins. So yeah, you can use wires to directly connect anything from this. So let us just see what is present in these individual ports alone. So as you can see here, I hope it has, as I said, it has 34 pins. Each have 34 pins, so 34 here and 34 here. So it has everything you have in your port C. Okay, this is port A, this is port B, and the opposite side, which you have, which look like how we had in my DAC, right? So this one is port C, right? So this port A and B, individually has actually DIOs as well as analog inputs and outputs. And also you have the general protocols which will be used in data acquisition. For example, SPI, UART. So these protocols are available to work with MyRio. So yes, MyRio is capable of handling with most general protocols. You have so regarding speaking with your sensor, right? So some sensor will be able to speak with a device which works in a certain protocol. Say for example, UART or SPI. So these are basic protocols present in most of the sensor available here. So you can also use the protocols. As you can see, you have the SDA and SCL here. So which are the part of I2C. This I2C protocol can also be used here. And you have SPI pins. You also have UART pins here, the UART transmitter and receiver pins. So yes, these protocols are available in MyRio. So which is not actually a part of MyDAC, which you have seen yesterday. So here are the description of sequence. Okay, the basic description regarding the limits, how much it can be generated, the most general things, and it also have a power supply. So my deck also had a power supply of plus 15 to minus 15. So this is regarding the port C. The port C is as a ditto, as same as what you had in your my DAC. Okay, a my DAC is capable of generating just one PWM, but in your Rio, you have one PWM here, and if you see here in this port A and B, so you have actually two additional PWMs. So totally, you'll be able to generate five PWMs from a single MyRio device. So yeah, apart from that, apart from this analog input, analog output, and uh, the digital I/O. So you also have this audio in and out pins. So just as same as you saw in your my deck. So now let me just say you some specifications or the sampling rate and all those things regarding the analog input and output channels. So just give me a minute. So sorry for that. I just made my device ready so that I can show you the connection after this reading out the specifications of this device. So fine. Let me just go to the page where it exactly says about the sampling rates and everything. So this document also have the physical dimension. So size wise, both the MyDAC and the MyRio will be of the same size. So it will be actually smaller than a typical mobile phone we are using today, a normal Android phone. So this MyRio is actually smaller than my mobile phone. So the thickness will be somewhat more. So it will be looking like how you. So what will be a size of keeping two iPhones on top of each other? So that's the size of the MyRio. The thickness will be somewhat larger. Fine. So regarding the size, it will be just smaller than your mobile phone which you carry. So that's regarding the size of a MyRio. Let me just go to the specifications page. So here it is. This is what I want to show. Let me just zoom it up a bit. So yes, so let me just say you the some basic specifications of this device, Mario. So I told that it will be having a processor, inbuilt processor. So which is Xilinx Z7010. So that's the processor present here in the Mario. So you can see it in the picture itself. So this is the processor, which is the Xilinx C7010. So this will be this in the exactly the center of the device, so which can be seen using that glass window you have, and the speed of a processor. So every processor have a clock speed, right? So that is 667 megahertz. So the processor has been clocked at 667 megahertz. Okay, so that is the speed or the clock speed of the processor. And regarding the code, it is a duo code. That is just two cores. Okay, I think that will be enough for running your lab codes. Okay, so that's its work. This is not going to carry your Windows or do any gaming and all. So this is just going to run your lab code. Okay, and also your FPGA code. So for that, I think this processor speed and the number of cores are more than enough. And regarding the non memory, so this also have some inbuilt memory to it, so that your code should be stored, right? There must be a memory. And yeah, this also has a RAM to it. So regarding the non-volatile memory or the ROM, it has a 512 of a GB of memory, which can actually you can use it as a storage also. You can access it using your LabVIEW program, or even using if you have connected your MyRio to your laptop, you actually have to enter that IP address, and you will be able to access the file items present in your MyRio. And this also has a RAM of 256 MB, and the clock frequency of the RAM is 533 megahertz. So that's about the processor and memory present here. And yeah, this processor actually comes with a FPGA. Okay, so that's why we have the FPGA type named exactly same as what we have here. The processor and FPGA actually comes together. So and yeah, as I said, this also has a Wi-Fi module within it, a channel width of 20 megahertz. So I think these things doesn't matter. So let me just quickly go to the analog input part. So this is what exactly needed when you speak about the data acquisition. So this also is a data acquisition come embedded device, as it can just work separately without even a laptop. Right? So once you have a code, okay, once you have a code ready, you can just import that code into this NIMIDEO, and yes, you're done. So your device can actually run your code without the help of your laptop. So this is the most important thing, or the most important advantage. So regarding speaking, technically speaking, so now we just saw the hardware overview, how it look, what all the pin it has. But what is the great advantage? Okay, so even if it has number of pins, you can say that even Arduino has that. So what is the advantage here? So these are all the advantages which we have in the NI MyRio. So the first thing anyone would like to hear regarding a data acquisition device is nothing but it's a sampling rate. At what maximum rate your device can sample. And so we saw that MyDAC has a sampling rate of 200 kilo samples per second. So even that is actually very high, right? So that is also an industry standard sampling rate. But regarding your MyRio, the analog input, it has a sampling rate of 500 kilo samples per second, so which is actually a great thing. Speaking about the performance it can deliver for your data acquisition application, and the resolution is the same. It's 12 bits, and it has a over voltage protection. Okay, the maximum voltage you can acquire is actually plus or minus 10 volts. Okay, though so the range of your analog input is plus or minus 10 volts, but it has a over voltage protection for plus or minus 16 volts, so that your device does not get burnt when actually a over voltage supply occurs. So here we have the nominal range. The nominal range which can be used with your analog input is plus or minus 10 volts. And the audio and the audio in and audio out pins are there, right? So there the nominal range will be plus or minus 2 volts. So that is actually same as you had in your MIDAC. Now let us move on to the analog output part. So here there is a bit of drop in the sampling rate, but this is also higher than what we have in your MIDAC. So the sampling rate here in the analog output channels is 345 kilo samples per second. So which is also a great sampling rate, okay, because the analog output, so we are going to generate a signal and send out. So for those signals having a sampling rate of 345 kilo samples is actually great. And the resolution and the over voltage protection is the same as you had in your analog input. And the range also will be plus or minus 10 voltage, and the current drive it can provide will be 2 milliampere. So this is for individual channels. So that's regarding the specifications of the analog input and the analog output pins present in the MIDIO. So speaking about the digital I/O, so you have actually uh, 16 DIO lines in those MXP connectors, which is port A and port B. You have 16, and you have 8 separately. So sorry, uh, each port will be having 16 DIO pins, and you have two ports. So totally, we have 40 DIO lines in your MIDIO compared to just 8 DIO lines present in your MIDAC. Your MIDIO has 40 DIO lines, and yeah, which is TTL compatible. So which actually works with 3.3 voltage. 3.3 voltage to it will mean that it will be on, and this can tolerate up to 5 volts. Each DIO pin can tolerate up to 5 volts, and as I said, this has this SPI, and it can generate PWM. So there are you have totally 5 PWM generation capable pins here in the MyRio. And as I said, you also have the accelerometer, an inbuilt accelerometer, which comes pre-installed into your device itself. So yeah, it's a three-axis accelerometer which has a range of plus or minus 8G. So I'll just show you how this accelerometer works. Once I connect this device to my laptop, right? I can just show you how to do the basic configurations and some basic thing about the device itself. I think that's regarding the specification of the NI My Rio. I hope that was clear. So let me just quickly make the device ready and connect it to my PC. So just give me a minute. So yes, I have my device ready here. So let me just connect it to my PC now. So I've actually connected the power supply for 12 volts using the adapter. So now I'm going to insert the USB cable into my PC. So I've just inserted the PC. Yeah. So as soon as you connect your device to your computer, right, you'll be getting this window saying that I've connected a Rio and the serial number of the device, also with the IP address. Okay, and you have certain options here. So let me choose this launch the getting started wizard. So it will be showing you some default configurations of the NI Mario. The first, it will be showing whether it has found any Rio device or not. It will be showing you with the serial number. So once I click there, so it will be connected, try to connect to that device, and it will be checking the software. Okay? So you can, if you want, if you wish, you can change the name of the device here. And let me click next. So once it has connected to your device, and once it has established the connection successfully, you'll be having this window, okay, which is the same window, but you have all these things present here. So this is nothing but these three are nothing but the readings of the accelerometer present in your in my media actually. So now I'm just moving my media up and down, so you can see the difference that it makes here in these three sliders. So this actually is also LabVIEW code. So yes, so there is an inbuilt accelerometer. You can check whether it is working or not using these three values. Okay, I'm just moving my accelerometer now, and I can see some changes going on here. So now I'll just place it in the flow. You can see the x and y should be 0 and the z should be at 1G. Fine. So yes, apart from this, I have this four buttons. So which says on and off. So these are nothing but the switches used to control these four LEDs. Okay? So as I turn here on, so each of the four LEDs present here will be turning on, and if I switch off, the LED will be switching off. Fine. So and regarding this, I told that there is a user programmable button present here in the reload. So when I try to press that, so now I'm actually pressing that button present in the my Rio, the user programmable button which I said. Sorry. If I press that, you can see the LED present here is actually turning on and off. Yeah. So now I can say that all the onboard devices present in my Mario is actually working. Once I click next, so yeah, it says congratulations, Rio is ready to use. Whether you want to start your first project or go to LabVIEW 2019. Why it says automatically 2019 here? Because when I search for LabVIEW, I have different versions. Okay, I have 2018, 19, as well as 20. But when I connect my Rio, it automatically says that the version is 2019. Okay, so because so if you connect your Rio to your system, right? So there should be a software set or a driver which should be installed both in your system as well as into your MyView, because we'll be having different versions of LabVIEW. So as I have the three different versions of LabVIEW. So this particular version, okay. So say for example, you have only 2018. So that particular 2018 Rio toolkit should be installed in your MyRio. So that you need not download anything from the internet and all. So once you connect, so right now I have the default setting installed. Okay, I have 2019. So say for example, I don't, you are using LabVIEW 2018 and your Rio has the software for LabVIEW 2020. So if that's the case, actually while launching this window itself, Yes, while launching this window itself before the screen, or sorry, after the screen, it will just show you that the required software set required for communicating with LabVIEW is not installed and you must install it. Okay, so when you install this, it will actually take some time. So if you want to install a new software set into your Rio, it can take up to 10 to 15 minutes for getting installed. So once that installation is completed, so that the software set you install in your Rio should be the same version of LabVIEW which you're using. Okay, that's the case. And once that installation is finished, after you click next, you should be getting this window and every option should be working. So this is how you check whether your Rio is actually working properly or not. So now let me show you how to configure the device. As I told, if I want to connect it wirelessly, right, I have to configure this device to generate a hotspot or connect to a wireless network. So I'll just show you how to actually configure your device. So for doing that, you would have to open a software called NIMAX. So I'm not sure whether you have seen this about this yesterday, but there is a software which actually get pre-installed with your LabVIEW. So if you install LabVIEW, right, this particular software also will be installed with that, which is called NIMAX. So the Max means that measurement and automation explorer. Right? So from this software only, you'll be able to configure any remote device or any data acquisition device which you have connected to your PC. Okay? So once I open the software, right, so I have to go under. So it will usually in the home page, it will be showing regarding my system settings. So what my system configurations and all. I'll be going into my remote systems. So here it will be showing the name of my Rio. So right now only one device is available. You can see these are all not connected and this device alone is connected. So if I click that device, that will be taking me to the configuration part of my Rio. So here you can see the different settings. Okay, so first, if I take the system settings, you can change the name here. Say, for example, the host name is actually Rio. If you want to change to my Rio, so I can do this, and it has the IP address of the my Rio and the DNS name also, and it shows me the model. There are actually two models of NI my Rio. So one is 1900, which we are using right now, and also the serial number of this hardware, the firmware, and yeah, here you can see the exact operating system name. As I told, it is Linux based, the N9 Linux real-time V7. Okay, that is the operating system which is running in this my Rio, and the status you can confirm from this that the device is connected and it is running. And you have some default startup settings. So you have something called the safe mode and disable RT startup. This is nothing but to disable your code, disable your Rio from running the code which it has. Okay, so those settings will be present only here in this NIMAX, and this also shows how much memory is available and how much memory has been taken, the free memory and the total memory. So these things can only be seen in this window in this NIMAX software. So after I have made some changes, right, I have to click on save for it to save the settings to the read. So once it changes the name, I have to reconnect it. So let me remove my Rio and let me connect it again. as you can see, the name has been changed here. Yes. So as you can see, there here the name has been changed. So let me just minimize this, and here also you can see my name has been changed. This is how you change the name of your device. So this is regarding the system settings, the general system settings of my radio. So how to do that wireless connection now? Okay, so that's the question. So that you have to change the tab here to the network settings. So just change the tab, and here is where you have to do the configuration for connecting to your MyRio wirelessly. So I'll just show the steps of connecting your device to your PC wirelessly. So here you can see there is a wireless adapter. Okay, so let me just take magnifier. So as you can see here, there is a wireless adapter which is currently disabled. Okay, so here you'll be choosing whether your Rio should connect to a wireless network or create a wireless network. So right now I cannot do both of the things, because if I connect to that wireless network, my Wi-Fi will be off and I'm not able to stream you the session. So let me show you whether this is working correctly or not, so that I can show you now. So for doing that, I have to create a wireless network actually. So yes, so now I have said ask my Rio to create a wireless network. So I have to choose the country. So we are in India. Yes. Right now status is not connected. So let me give a name for the SSID is nothing but, say for example, now my Rio, right, it is going to act as a hotspot for my mobile phone. I'm going to see that particular connection here in my networks. Yeah, here in my networks, I'm going to see that particular connection, and I'll not be connecting to it, so which I cannot do now. So let me give a name here. So I'll give it 1, 2, 3, 4, 5. I hope it can have numbers, and I'll give the security as open itself. You can also have a password if you wish. Right now, I'll give it open, and this I'll give it as DHCP or link local. Okay, I'll give the default setting as it is. So right now, I've changed all the settings here which needed to change, and I'll save it once. This should be DHCP only, and I'll save it again. So right now, I think the device will actually restart. Let me give some time for it to actually restart, and let me check whether the hotspot is present here. So the name I have given is 1, 2, 3, 4, 5. Oh, yes. So as you can see here, my video actually created a hotspot, so which is showing up here. So if you want to connect your device to your PC wirelessly, it's enough that you just click connect here, and your device and your PC will be connected. So after that, will be connected, and after that, you can remove your USB cable. So after your device and your laptop is connected wirelessly, the USB cable is not needed. But until then, it is needed, because only if your My Rio is connected to your PC using this USB cable, you'll be able to change these settings. Unless you change this disable to create a wireless network, so that wireless network will not be created by your device, and you'll be unable to connect to it wirelessly. So for doing this, only you need this NI Max, and also for changing some uh, basic attributes of this device. Once again, I repeat the process of how to connect to my Rio wirelessly. The first, you have to just click this Dropbox of remote systems and select my Rio. So that will just open a separate window for your my Rio device. And from there, you have your system settings. So if you wish to change the name of your device, you can do it from here. And you also have some startup settings, and you can also view how much of your resources available in your device is free in the present time. So after this, if you want to connect your device wirelessly to your PC, so I have to just go to the network settings tab, and here by default this will be disabled, but I have to change to either you can connect to a wireless network or you can create a wireless network. So the usual way, if you have only one PC and one Rio working, okay, so that is important. If you have multiple devices, or say for example, now I have to connect my Rio to the same network. Now I have connected to a Wi-Fi called AA Solutions, right? So yeah, if I want to connect my Rio to the same network, so I can do that uh, by just choosing connect to a wireless network, and I can do that. But right now that particular network is secure, so I can just show you how to do that also. So from this, you would have to choose the wireless network. So if I choose AA Solutions, so I would have to enter the password. Okay? So that also you can do. So this, how it will work is, so say that you have your hotspot from your mobile. If you connect both your PC as well as your MyRadio to the same network, yes, that can also work. Then also you can say that the PC and your device is wirelessly connected. So that should also work. Or say that you have only your device and your PC, which needs to be connected. I don't want any external or any additional device are needed to be connected. So in that case, I'll just choose create a wireless network, and this is going to create a hotspot. Okay? My device, my MyRio is going to create an hotspot, which I can just connect from here. You can see now it is available. So if I just disable and save the settings, that should not be available. So let me try to save the settings. I hope it was already by default in disabled, so that's why it's not getting saved. So let me close this window. So right now I have my PC connected wirely to the MyRio. So the reason I do not connect wirelessly is that I am already connected to a secure network. So I don't wish to interrupt it, as this will disturb my streaming into this session. Fine. So now we'll just move on to the last part or the final part. So I hope everything is clear regarding the basic specifications and interface, interface and everything. So I'll just say you how to start coding. I think this will be repeated in tomorrow's session also, when you just start with the hands-on and everything. But I'll just show you the basic part of that, and then we'll just discuss about the advantages of this hardware. Okay? So yes, even though you have this hardware, right? So take for example, you take any other hardware, take Arduino or Raspberry Pi. So once you connect your hardware to your PC, you'll be writing your program in a different environment, in a different IDE. And then what you will do is you will just burn your code inside that particular device and make it run. Right? So that's how you run any code using some of the common controllers out there. But here you actually have different types of actually executing your program or your project, your application or anything. Fine. What are the different ways? Fine. You can have it in your laptop itself. You can control a device from your laptop itself as a runtime. If you run your program in your runtime, you can control it from your laptop itself, or you want your device to be a standalone. I don't want to control it from a laptop. You can just burn your code inside your device and you can make it work as a standalone, or you wish your data acquisition and the processing of your device should be more precise and the performance, if you need it to be better, you can just execute your program in the FPGA instead of doing it in a processor. You can do it in an FPGA. So there is actually different modes of executing the program present using if you use this Mario, there are actually different ways to actually do a single thing. So how do we get started? How do we get started to actually program this device? Okay, so that's the question. So the software which we are going to use, so there is no separate IDE and all for this Mario device. So yeah, as you coded for your MyDAC, you're going to code for your Rio, but not exactly the same. Your My Rio cannot be programmed without a project. Okay, so you need a separate project in LabVIEW. So I hope people wouldn't come across what a project means in LabVIEW. So let me open the required version, which is 2019. Let me open that LabVIEW version now. So as you can see, once you install your MyRio toolkit to your LabVIEW software, right? Whenever you open your LabVIEW software, it will be showing this that you have your MyRio toolkit installed. Once you get into this LabVIEW getting started window, so what you have to do first is to create a new project. Okay, just click create new project, and you'll be getting a configuration window that how your project should be. Right now, I wish to work with MyRio, right? So I have a template. You have a template for the MyRio. So just click that and just click to a MyRio project. So this will just take all the default settings, all the default configurations. So that is why this has a name called template. This is actually template. So in which you're going to incorporate your code and get it as a final project. A project is nothing but a collection of VIs in a documentable manner. Okay, you can call it like that, present in LabVIEW. So this is not same as a project you find in any other software. But here in LabVIEW it's something different. So once you select MyRio and here under templates, you have to be selecting this MyRio project. So if you want to code under FPGA, you'll be selecting this. Okay, so right now I'm not going into FPGA, so that is a more deeper concept. So I just choose this my Rio project and let me click next. So once I click next, here actually you'll be seeing a lot of information. Right? So in this window, so this is where you configure your project actually. You can give it a name, give a name for your project and just say where your project needed to be saved. Let me change this location to my desktop. I'll just change this location to my desktop. I'll get a new folder on this current folder. Right? So I'm just trying to save this project in desktop. So you can also have a prefix for your file name if you wish. So here is the most important thing. So it says target, right? Target means that on which device you're trying to code it. So right now, I have plugged my USB into my system, right? So that it is showing me the name of the device and also its IP ID. So now I'm just removing it for a second. I'm trying to remove it. I just removed it. I don't know if you hear that sound. I heard it. And let me refresh. So now you can see there is no device present. Even if I move to connected over Wi-Fi, so these two are actually physical devices. So now once again, I'll try to connect it. So now, as you can see, my device is present. Once I refresh it, it will be searching for targets, and yeah, it will find my device because I've connected it using my USB cable now. So say that you have removed your USB cable and you have your MyRio connected wirelessly. So in that case, you have to choose this option, and the device will be shown here. What is a generic target? A generic target is nothing but, so right now I am having the device with me, right? I am having a MyRio with me, so that I can actually use this option or this option. Say for example, your students are trying to code this from their home, so they cannot take this hardware to their home. So in those cases, what they can do is actually choose this option. So you can also right now, if you don't have access to this hardware, so you can use this option, the generic target. Generic means that it is not physically present or a virtual hardware. Fine. You can use the generic target, choose the required Rio version. So as we saw, the Rio version, which the basic version is 91900. Just choose the version and you can start coding without even having the hardware. You'll be able to code. Fine. So right now, as I actually have the hardware, I'll choose this option. So here you can see the personality or the specifications of this MyRio, what are all exactly present here. So this will give a better picture of what we saw in the document, right? The specification document. So the same thing has been correctly mentioned here. So it has totally 12 analog input channels, okay, compared to just two analog input channels in the MyDAC, and sorry, and eight analog output channels compared to again two analog output channels in MyDAC. And this has 40 digital input and output pins, okay, compared to 8 DIOs in the MIDA. And this has one physical button or the onboard button and four onboard LEDs, 3-axis accelerometer, and this has 8 PWM channels and four encoders. I don't know about the encoders used to read the response from a motor. It has four encoders, and this also have, as I said, two SPIs, two different SPIs. So you'll be able to interface with two different sensors, which actually runs using SPI. And this has two I2C protocols capable pins, and the device is capable of running two UART protocols also. And there is also interrupts are present in this video, but trust me, we will not use this as much. Okay? But just know that we have 8 interrupts present in uh, the MyView. So this is regarding the general specification again of the MyView. So now this actually is not allowing me to finish because I must do it in an empty directory. So I think I must have to create a new folder here, and I can go inside this folder. I think now it should be possible because the folder which I selected before was not empty. So it was saying that anywhere if you want to save your project, that particular folder must be empty. So that's why I just created a new folder. So after this, you can just click finish. So it will be creating you the new project. So this is how a project window in Apple looks. Okay. So right now I have this two different targets. Okay. So my computer is actually target, and the my Rio is also a different target. So now I have to code under my Mario. So coding under your my computer is your normal code, which you directly open LabVIEW and code, right? So it's the same as that, but coding under Mario is different. So let me just quickly show you the difference between this and this. So let me create a VA under both. Okay, I'll create a new VA. So this was created under my computer. You can see it here. Okay, let me zoom in. So untitled one front panel on untitled project, the project name slash my computer, right? So let me minimize this VI. Now let me create another VI under my Rio. Okay, so this says the same thing but slash my Rio. So what is going to be the difference between these two? Right? So let me take two block diagrams. Okay. So this block diagram is with my computer, and this block diagram is with my Rio. So let me take it somewhat side by side. So what is the difference is, so this is under my Rio, right? So sorry, this one is under my Rio. You can see the name. So there, if I right click, I'll be having an palette, a separate palette called my Rio, where I can work with the my Rio, fine. But in a normal VI, okay, in a normal VI slash my computer, if I right click, I'll not be finding that particular palette. The MyRio palette will not be present in my computer. So only when I create a VI under MyRio in a project window, if I create my VI under MyRio, so that VI, that is this VI alone, will be having a palette called MyRio, using which you can actually program whatever you want. So as you have directly some direct blocks called analog input, output, digital in and out. So this button is nothing but the onboard button present present in the MyRio, and this is also regarding the onboard LEDs. This is the onboard accelerometer. So let me just show you a basic program. Let me close the my computer VI which I have opened, and yes, so I'll take this block which is the accelerometer and place it in my block diagram. And here it will just ask me to give a custom channel name. So let me give as Y and Z for the channel name and give OK. So this is the configuration of the accelerometer. So now I'm just going to show you the same thing which we saw in that my Rio getting started window. So once I connected to my device into this computer, right, we saw some values, some slides regarding the accelerometer values. So the same thing I'm trying to bring in to the lab view. So let me take three different waveform charts. Okay. This I'll name it as X, and this let me name it as Y, and the third one I'll name it as Z. So these are three types, three axes we have in our accelerometer. So after placing this, let me connect the respective axis values to the charts. So after this, I would like to put them inside a loop. So I'll take a while loop, and if we have a while loop in the block diagram, I'll also have a stop button. I'll create a control and take out the label, and let me place the stop button here. Right? So I have to add a timer. So I have to slow down the loop. So I'll go to timing, go to waiting. So you can see that some functions are actually missing from all the palettes. So you cannot use all the functionalities in a MyRio palette. Create a constant, and I'll give the timer for 100 milliseconds. So now let me run the code. So this will actually deploy your code in your Rio. So every time you make some changes and try to run again, so this will actually deploy your code into your device, and then only it will try to run. So just check this close on successful compilation so that the code will automatically run. It also compiles. So, and this is another thing you have to remember while working with a MyRio VI. It is that whenever you're trying to run a code, right, you must actually save the code before you're trying to run. So just save it in the desktop itself, no problem. So you can see that the accelerometer value is here. So give me a minute. So yes, as I said, we have now all the three axes of the accelerometer displayed here. Right? So this is just the same as how we saw in that getting started window. So yeah, the same values have been. So now let me try to move my accelerometer. Right? And I'm just moving my accelerometer up and down. You can see the changes here in the z-axis. So now I'm stopped moving. Now it is somewhat steady. Again, if I start moving, this is going to. So this is how you program using your MyRio. So this is actually somewhat different when you compare with how you program with your DAC. So for your DAC, you can just open LabVIEW, create a new VA, and straight away start your programming. But while programming with MyRio, you have some prerequisites for you to follow, like creating a project, adding your MyRio as a target. So these are all the prerequisites you have to be following for programming with MyRio. So I hope it was clear up to now. I think I got text here. So thank you so much for your message. Uh, I hope it was clear up to now. So right now, whatever code I'm running, right? So this is not running in my FPGA. Right? It is not actually running in my FPGA. So coding with FPGA is different and is a complex programming part. Okay, so that cannot be completed in a single day, uh, or even if you give it to us, also that's actually hard to make understand. So that is actually a complex way. But yes, you have to know that it can be done. Why I'm saying it as a complex way is so you people might know that every FPGA coding will have a bit file. Okay, so your FPGA will not directly run a LabVIEW code. It cannot run a LabVIEW code. So what will happen is you'll be converting your lab view code into a bit file, and that bit file only any FPGA can run. So even if you use any type of controllers, what you're going to convert your code into a bit file only. That bit file only will be able to run inside an FPGA. So here also, when you use the FPGA programming, right? Let me close this window. If you try to do FPGA programming, what will actually happen is your LabVIEW code will be converted into a bit file, which will take actually a lot of time. So even say you're doing an FPGA code for just blinking one LED, you're using just one DA open, so that will take actually 20 to 25 minutes to compile. So this is the case with every microcontroller or a controller which has a capability to program with FPGA has. Okay, the problem of creating a bit file and then uh, deploying that to Rio, and then it has to run. So that actually takes a long time. So FPGA, we will recommend to use the FPGA only if the requirement actually requires it. So if your requirement is strictly going to follow FPGA, it is like it has to eliminate the entire parallelism. There should be no space for parallelism. If your application or if your development process requires that, in that case only the FPGA is required. So until other than that, no. So this RT, this processor and this operating system which is present in MyRio will be more than enough. Okay, because the sampling rate which we have here itself will be more than enough. But once your programming gets complex, so that you are using high number of I opens. So in that cases, maybe we would recommend to use the FPGA. Right. So I hope it was clear regarding the introduction to this NI MyRio. So in tomorrow's session, actually, I'll not be handling. My colleague will be handling, and maybe will be. I think the sensors will not be available, but yeah, you'll be knowing about the programming part. Okay, right now I've not did a lot of programming. I've just created a VI to show you the onboard accelerometer value. So still, we have to know how to generate a signal here using Mario, and also acquire the same, and uh, how to use this. How to make these two speak. Actually, the data you're getting here, right? You cannot even save into your PC because this is entirely different target. Okay, the data which you get here cannot be saved in your PC. It can be saved in your Rio, but there is a way of how you can make these two speak. Your computer is a target. Okay, right now my code is not in my computer. It is in my Rio. So when I try to save any data to a file, there is actually you can actually save data into file in a usual program. But right now, as my target is my Mario, I will not be able to save the data into my file. There is another way of doing that, so that we call like RT to host communication, so which will be explained tomorrow. And maybe the loopbacks can be done tomorrow in tomorrow's session. I think tomorrow there will be a normal length session, like 11 to 12:30, I think so, and as usual, 2 to 3:30. So yes, regarding the generation and acquisition of signals using the AI, AO, and the AI opens, and so to be basic, the programming basics of the AI video that will be covered tomorrow. So I hope today's session was clear and no one has any doubts. So if there are any doubts, you can ask me now. Put it up in the chat window, or we just finish up the session by now.
Any participants, if you have doubts, you can discuss with sir. There are no doubts, I guess, sir. You can conclude.
Okay, so thank you. So yes, thank you everyone for this for attending this session. So yes, tomorrow also the same part will be continued regarding the programming with an NAVO. So I'll just conclude today's session with this. Thank you everyone for attending the session. Have a nice day. Take care.
Thank you, sir. Thank you for this presentation, sir.
Okay, sure. Thank you.